Welcome to all of you. Today we discuss the answers of MCQ paper CC-1 2019 Mathematics Honors, University of Calcutta. Here 2019 paper CC-1. First question is the points of inflection of the curve y square equal to x minus b into x minus a whole square lie on the line. Correct option is 2, 3x plus a equal to 4b. Because from the given curve, we can write y equal to x minus a into root over of x minus b. And differentiating with respect to x, we get dy dx equal to 3x minus a minus 2b whole divided by 2 into root over of x minus b. And again differentiating with respect to x, we get d2y dx square equal to 3x plus a minus 4b whole divided by 4 into x minus b whole to the power 3 by 2. And d cube y by dx cube equal to 3x plus 1 a minus 2b whole divided by 8 into x minus b whole to the power 5 by 2. Now, for the point of inflection, this is the d2y dx square equal to 0, which gives 3x plus a minus 4b equal to 0, because d2y dx square a is this, so d2y dx square equal to 0 gives the numerator obviously equal to 0. So x equal to 4b minus a by 3. And for this x, 4b minus a by 3, and d3y dx cube is not equal to 0. And at this point, x equal to 4b minus a by 3, value of y is equal to plus minus this. So for the point, these are the point of inflection which lies on the line 3x plus a equal to 4b. If we draw the curve fx equal to x minus a root over x minus b, then we get this red line is this. This is the red line. This is the first to draw the curve fx equal to x minus a root over x minus b. This is the red line curve. And the first derivative is dx, ddx of fx, and second derivative is hx. So second derivative is this for this curve, and the second derivative is 0. That is when this curve, this blue curve, cut the x-axis at this point, this. So second derivative 0 means hx equals to 0 for this x point, and for this point, and we draw a vertical line to the curve which is on red color. So this is the point of inflection, and this point is the for this portion is the concave from downwards, and after this branch is concave from upwards. And so this is the straight line 3x plus a equal to 4b. We get this straight line. So this point is the point of inflection. This point of inflection and lies on this curve. So red curve is the given curve, and this the brown line curve is the second derivative, which is equal to 0, means the cut the x-axis at this point, and 3x plus a equal to b is the vertical line. So a point of inflection lies on the vertical line on this vertical line. Next question, the nth derivative of x to the power 2n where n is a positive integer is first option 1 root to the power n 1 3 5 2n minus 1 into x to the power n. Here y equal to x to the power 2n, n is positive integer. So dy dx, that is y1 equal to 2n x to the power 2n minus 1, y2 d2y dx square is given by this, and dot 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 dot. Nth derivative yn is given by 2n, 2n minus 1, 2n minus 2, and dot 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 2n minus n minus 1 into x to the power 2n minus n. So 2n, 2n minus 1, and n, this that n plus 1, last factor is n plus 1. After that, we multiply by these factors n minus 1, and dot, 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 up to 2.1. And so we divide by these factors n minus 1, and 2 and 1. Because the numerator is, from this numerator we get factorial 2n, and from the denominator we get factorial n into x to the power n. So value of yn is given by this factorial 2n by factorial n into x to the power n is the is equal to this. Now this 1 3 5 2n minus 1 into 2 to the power n equal to 2n minus 1 2 to the power n 2 4 6 2n whole divided by 2 4 6 2n. And if we rearrange this term numerator 1 2 3 4 2n minus 1 and last 2n and divide by this into 2 to the power n. So from the numerator we get 2n factorial into 2 to the power n and divided by here 2 to the power n into 1 2 3 n, because from 2 into 1 4 2 into 2 6 2 into 3, so we get 1 2 3, and this is there are n terms, so 2 to the power n, so we get 2 to the power n 2 to the power n cancel, so factorial 2 to the power n and by factorial n. So 1 3 5 dot 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 2n minus 1 2 to the power n equal to 2n factorial by n factorial, and hence from 1 yn equal to this 1 3 5 into 2n minus 1 2 to the power n into x to the power n is the required answer, which is given by the option 1. Next question. Envelope of a lambda square plus 2b lambda plus c equal to 0, where a, b, c are functions of x and y, and lambda is a parameter, is the correct option is 2, b square equal to ac. Here the curve is this a lambda square plus twice b lambda plus c equal to 0. Here lambda is parameter and a, b, c are the function of x and y. And we are differentiating one with partially with respect to lambda. Lambda, we get 2a lambda plus 2b equal to 0, or lambda equal to minus b by a. And putting this lambda in 1, we get this expression, and after simplification, we get the result ac is equal to b square, which is the correct option is 2. Next question, the line y equal to 0 is not an asymptote of the curve. Correct option is 4, x equal to y by y square minus 1. Here, the necessary and sufficient condition in ASC of the horizontal line y equal to b to be an asymptote to the curve x equal to phi y is that modulus of phi y tends to infinity as y tends to b. Y tends to b, as y tends to b, x it tends to infinity. Then we can say y equal to b is a horizontal asymptote. Now from option 4, this curve is x equal to y by y square minus 1 equal to 5y. Say now limit y tends to 0, 5y equal to 0 by 0 minus 1, so this is equal to 0, not equal to, not tends to infinity. So y equal to 0 is not an asymptote of x equal to y by y square minus 1. If we draw this curve, this curve is x equal to y by x equal to y by y square minus 1. So clearly we see that this this line this curve is this. So here this line is y equal to 1, and this line is y equal to minus 1. So there are two asymptotes, y equal to 1 and y equal to minus 1 here. So y equal to 0 is not an asymptote of this. Y equal to 0 means x-axis is not an asymptote of this curve. Next question. A necessary condition for which the lines x equal to a1z plus b1, y equal to c1z plus d1, and x equal to a2z plus b2, y equal to c2z plus d2 are perpendicular is, the correct option is 2, a1, a2 plus c1, c2 plus 1 equal to 0. Here, this is a plane and this plane. So this is the first line, equation of first line, this given by this, and this is the equation of second line. First, we write the first line in symmetrical form and second line in symmetrical form. So from the first line, x equal to a1 z plus b1, we can write z is equal to x minus b1 by e1, and y equal to c1 z plus d1, so z is equal to y minus d1 by c1. Combiningly, we get right. We can write in symmetrical form for the first line x minus b1 by a1, y minus d1 by c1, and z minus 0 by 1. So this is the symmetrical form of the first line. This first line obviously passes through the point b1, d1, comma 0, and the direction ratios are y1, c1, and 1. Similarly, we can write in symmetrical form from the second line x minus b2, y minus d2, z minus 0 by a2 by c2 by 1. And if 1 and 2 are perpendicular, and then the product of the sum of their direction ratios must be equal to 0. So a1, a2 plus c1, c2 plus 1 into 1 equal to 0. Because we know that if there are two lines x1 by L1, y1 by M1 equal to z1 by N1, and x2 by L2, y2, y minus y2 by M2, z minus z2 by N2, and theta with the angle between them, then cos theta equal to L2 plus M1 M2 plus N1 N2 whole divided by root over of L1 square M1 square N1 square and root over L2 square M2 square N2 square, if L, M, N are not at the actual direction cosines. Actually, we consider here this L1, L2, M1, N2, N1, N2 are the direction ratios. So this is the cos theta. So if theta equal to 90 degree, so cos 90 equal to 0. So obviously numerator must be 0. So L1, L2 plus M1, M2 plus N1, N2 equal to 0 if theta equal to 90 degree. Theta equal to 90. So the sum of the products of the direction ratios equal to 0 if theta equal to 90 degree perpendicular. Next question. The diameter of the circle x square plus y square plus z square equal to 25, x plus 2y plus 2z plus 9 equal to 0 is, the correct option is 2, 8 units. Here The first equation is gives a sphere with center at origin and radius is 5 units, and second equation gives a plane. So combining equation gives a circle. Here, this is the sphere, and the O is the center of the sphere, and the OP is the radius of the sphere, is 5 units, and this is the plane. So uh, distance of the plane from the O is when. So obviously distance is this ax1 plus by1 plus c z1 plus d whole divided by root over a square plus b square plus c square modulus. So this is equal to 3 units. So when equal to 3 units, this is the distance from the center of the sphere to the plane. This. Now the radius of the circle is this. The circle is this. So radius of the circle is np. So obviously by Pythagoras theorem, np equal to root over of op square minus 1 square, and hence this is equal to 4 units. And hence the diameter of the circle is 2 into 4 equal to 8 units. Radius of the circle r equal to 3 sin theta plus 4 cos theta is the correct option is 2, 5 by 2 units. Here we know r equal to 2a cos theta minus alpha, that is 2a into cos theta cos alpha plus 2a sin theta sin alpha, cos theta minus alpha cos a cos b plus sin a sin b. So this equation 1 in polar form represents a circle whose center is at the point a comma alpha. A is the radius and alpha is the radius vector, and alpha is the vectorial angle of the center of the circle. So this is the point C. C is the radius vector is A. So AO is the pole. So OC is equal to A units, and the vectorial angle is alpha, is the polar line is this OX axis, and this initial line the radius A, and the pole O is on the circumference of the circle. And comparing with the given equation with the equation 1 in this form, simplified form, we get this. The given equation is r equal to 3 cos theta plus 4 3 sin theta plus 4 cos theta. So 3 sin theta, so 3 equal to 2a sin alpha and 4 equal to 2a cos alpha. And from this we get cos alpha equal to this and sin alpha equal to this, and squaring, adding, we get cos square alpha plus sin square alpha equal to 1. So value of a is 5 by 2 units, and taking the positive value of a, because a is the distance of the radius of the circle. So correct option is 5 by 2 units, that is option is 2. Next question H. The angle of rotation of the axis about the origin, which transform the equation x square minus y square equal to 4 to x dash y dash equal to 2, is correct option is 3 pi by 4. Here we take the rotation formula. Rotation formula is this: x equal to x dash cos theta minus y dash sin theta, and y equal to x dash sin theta plus y dash cos theta. And x, y is the original coordinates, and x dash y dash is the coordinates after rotation. So the given equation x square minus y square equal to 4 becomes, after rotation, x dash p minus y dash q whole square minus x dash q plus y dash p whole square equal to 4. We here take p equal to cos theta and q equal to sin theta. After simplification, we get p square minus q square into x dash square minus y dash square minus 4pq x dash y dash equal to 4. So this equation 2 becomes x dash y dash equal to 2. So obviously p square minus q square equal to 0 and pq equal to minus half. If we put p square minus q square equal to 0 and pq equal to minus half, then we get from 2 x dash y dash equal to 2. So p square means cos square theta and q square equal to sin square theta. So cos square theta minus sin square theta equal to 0, and pq equal to minus half gives 2 sin theta cos theta equal to minus 1. So cos 2 theta equal to 0 and sin 2 theta equal to minus 1. And so obviously cos 2 theta equal to 0 means cos 2 theta is equal to pi by 2 or 3 pi by 2, and sin 2 theta equal to minus 1, which gives theta equal to 3 pi by 4. 3 pi, sorry, 2 theta is equal to 3 pi by 2, so theta equal to 3 pi by 4. So correct answer is 3 pi by 4, option is 3. The components of the vector A equal to 3 I cap minus j cap along the vector B cap equal to j cap minus 3k cap is the correct option is 4 minus 1 by 10 and bracket j cap minus 3k cap. Here, question 1I, component of the vector A along the B vector is equal to A vector dot B vector by modulus of B vector into B cap. B cap is the unit vector along B vector. That is, B cap means B vector by modulus of B vector. So this expression can be written as A vector dot B vector whole divided by B vector dot B vector into B vector. Either this formula or this formula, you can use component of A vector along B vector. Now here A vector is this and B vector is this. So first we find A dot B vector, and this minus 1, and B cap equal to B vector by modulus of B vector, which is equal to this. So modulus of B vector is root 1 by root 10. So my A vector dot B vector is equal to minus 1, and modulus of B vector is this. Modulus of B vector is 1 by root 10, sorry, root 10, modulus of B vector root 10. So, and B cap equal to this, B cap equal to this, J cap minus 3 cap into this and minus 1, because this A vector dot B vector to minus 1, so minus 1 by 10, J cap minus 3k cap. Correct option is 4. And last question, if A vector equal to t square I cap minus tj cap plus 2t plus 1k cap and B vector equal to 2t minus 3 I cap plus j minus tk cap, then derivative of A vector dot B vector at t equal to 1. And correct option is 3, which is equal to minus 6. Now A vector dot B vector dot product, we get 2t cube minus 5t square minus 2t, and derivative with respect to t, A dot B vector, so we get 6t square minus 10t minus 2. At the point t equal to 1, derivative of A dot vector dot B vector equal to minus 6. Correct option is minus 3. Thank you.